Okay, in this video, I will cover the last two questions, question 13 and 14 of the 2021 end of year paper. Question 13 and 14 is actually a short question, rather short one. When we set this, maybe the setter is thinking that you guys are tired, so we tried to keep the question short. So question 13a is quite a straightforward question, but many of you misinterpret the question. So the question is asking you what is meant by a wave in a ripple tank. But many of you are answering me like, why is a water wave transverse wave? So these two are different questions. They shouldn't be confused with each other. So what is meant by a wave? Well, a wave is just a phenomenon whereby it transfer energy and not matter, and this energy transfer is done through transmission of vibration. And please take note, it is vibration, not collision. Okay, so you don't even need to tell me that the direction is perpendicular and so on and so forth, because they are not asking you why is it transverse. For B part 1, it is very important that you define the wave. Okay, this is the number of complete wave produced in 1 second. For this particular exam, we will condone the error if you didn't add in the adjective. Okay, but in set 4, we will penalize you. Okay, for B part 2, it is important for you to tell me that it is the distance between. So for example, you have a wave. In a wave, there's many crests. So if you are just telling me that it is the distance between one crest to another crest, do you mean one crest to another crest? So this to you is one wavelength? It is not, right? So it is important for you to have this word successive. Okay, so in this case, we will condone, okay, if you didn't have the word successive. Okay, but in the next exam, successive will become very important. For part C, we are checking whether you can apply, and it is a new problem, so it is not something that you have seen from your worksheet, but we want to see whether you can apply some of your knowledge. So for example, when we ask you to find a normal, we expect you to know that, oh, normal simply means that if you have an incoming ray, and if you hit something, then the normal will come from here, not anywhere. It must be, the normal must be at the point of the point whereby the light strike the surface. Okay, so unfortunately, I think the student is not very clear what is normal. Then you are supposed to draw the reflected direction of direction K of the wave. So this is the incoming K. So obviously the reflected direction will be just this. And you need to maintain the angle to be the same. And then after that, you have to draw the reflected part of E, F, and G. So E, F, and G will hit the boundary at these 3 points. So what you need to do is that you should know that the wavefront, right, will be perpendicular to your incident ray. So you can see that EFG is perpendicular to K. So what does this mean? This means that your reflected EFG will be perpendicular to this reflected K. So just use your set square and you should be able to draw the reflected EFG with no issue. So once you have constructed the first one, so for example this one, the red one that I have constructed over here, right, you can then from here draw for the rest. So I am done with this, so the next one I will draw is this one. So from this dot I will just draw a parallel line like this, and then after that from here I will draw a parallel line like this, and then I will get the reflected wavefront of EF and G. For part D, we are checking whether you can read longitudinal wave, and this has been tested in your term test. This question is also in your homework. So if you are unable to do this, this means that you didn't revise or you didn't thoroughly look through your worksheets. So first of all, you are asked to mark out the amplitude. Amplitude simply means that your maximum displacement from the original position to the new position. So what do I mean by original position and what do I mean by new position? So down here you can see that in part I, they gave you the original position of each layer of air molecule. Then in part 2, they give you the new position, whereby 1 is still at the same place. So what is this displacement here? Displacement of 1, 0, right? Displacement of 1 is 0. What is displacement of 2? Well, this is the new position, this is the original, this will be the new position of 2. What is the displacement of 3? Well, this is the new position of 3, this is the old position of 3. This will be the displacement between displacement of 3. So if you look at 1, 2, and 3, you can see that the maximum displacement occur at 3, and hence you can see that this will be your amplitude. Yeah. The second thing that you are asked to find is actually the wavelength. So in longitudinal graph, a wavelength is center of compression to another center. Well, of course, if you want to list it out, it will be CRC, center of compression, center of refraction, and then finally back to center of compression. And if you want to start with refraction, then it will be just the inverse. So here you can see that the student has identified the center of refraction, right? So this is R. And then down here you can see that this is your center of compression. So your center of refraction will come at here, right? So how do I know it is at 9? So you can see this is 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5, right? So you can actually see that this will be your wavelength. And you can also, if you don't like the 1, 2, 3, 4, 5 method, right? Let's say you have difficulty finding the center of refraction that is on here. You will notice that your center of compression and refraction, the displacement is 0. So meaning that your center of refraction over here, can you see? This is the only one that it is on the line. The rest of them are off their original position. So this is how I know that this is the next center of refraction. So therefore this will give you the wavelength. So in your part 2, you are given the speed. So the speed here given to you is in cm per second. So take note of that. And you're asked to determine the frequency. So unfortunately, I don't know what she's trying to do here. But what you should be doing is to use this formula, V equals to F lambda. The V is given to you as 2 cm per second. Do you know the frequency? You are supposed to find the frequency, and your wavelength can be obtained from your part I. So we can actually calculate what is your frequency over here. Yeah. So down here, since you do not know what is your wavelength, you can treat it as W. So therefore you would have F equals to 2 over W. You notice that I didn't change this to meter because my W is in cm. Right, my W is in cm. So when I bring it over, it will be 2 cm per second, right? This is 2 cm per second. When I bring the W over, W is in cm. So what happens is that these two units will cancel off, and down here we'll have F, right? So this whole term will turn into 2 over W, and the unit will become 1 over S. And 1 over S is actually your hertz. So therefore you do not need to do anything, it is just 2 over F. Okay, for question 14, we are checking whether you can apply F net equals to MA very carefully. So we give you a two object system, you have X and Y. Down here you are asked to actually draw the free body diagram of block Y. So block Y alone, of course, you will have the weight, and then you will have your normal contact force, and very well the student give me the perpendicular angle there. And you also notice that force F over here, you will have an applied force that is acting on block Y. Okay, and since block Y is pushing on X, that means if you look at X, right, X will actually experience a force from Y on X. This means that there will be a equal but opposite force like that. So this force will be from X on Y. So since we are drawing the free body diagram of block Y, we would have to include this green color force. So in total, there are 4 forces acting on block Y. So down here, you were told that the applied force over here is 28 Newton. And you also know that the block is accelerating together towards the left. And you are supposed to show the acceleration of the block. So in this case, they are asking you to look at it as one body, X and Y as one body. So when you do that, X and Y as one body, you will have a total mass of 7 kg. And the only force acting on this combined mass is actually the applied force. And you also notice that there is no friction because the surface is frictionless. So because of that, your free body diagram of these combined blocks will look like this, with the applied force of 28 Newton. You may be asking, teacher, do I need to consider the weight and normal contact force? You don't need to, because in this case, we are only analyzing the horizontal forces. Because the acceleration given to us is horizontal. So therefore, down here, if you are using F net equals to MA, your F net is just the applied force, which is 28, and you will have a combined mass of 7. So if you solve this, you will find that the acceleration is 4, and very well, you need to turn it into 2SF. Now in part 2, we are checking whether you read the question. So we are asking for the force acting on X. So some of you are using formulas like this, F net equals to MA, and you use the mass of Y, which is not right because we are actually checking the system of forces that is acting on X. So if you look at X will be pushed by Y, right? So you will have this force. So similarly to the top, whereby we drew it over here, right? So X will only have this force from Y on X. So here I will have the force from Y on X. In fact, this name, force from Y on X, is the same description as this. So because of that, you also can see that X is also moving on a frictionless surface. So therefore, your F net is just force from Y on X. So down here, you should turn this into force from Y on X is equals to the mass of X, which is 3. And because both X and Y are accelerating at the same rate, so therefore your A will be equals to 4. So therefore, this will be equals to 12. So that's how you solve it. So for B part 2, you don't need to overthink. You just need to apply with confidence. So part C is really a disappointment for many of you, because in both your homework and your test, we have tested again and again. So the action-reaction pair of the weight is not your normal contact force and is not the action-reaction pair of weight. Okay, we have said many times. Okay, because if you have Y here and if this is the Earth, the object Y is being pulled down by the Earth. We call this the weight of Y. So technically speaking, your weight of Y is basically the force from the Earth acting on Y. So as a result, you can see that the two party involved is Earth and Y. So therefore, the action-reaction pair of this weight of Y is actually the force that is pulling the Earth up onto Y. And it is really a force, okay? Any object with mass will have its own gravitational field. It's just that your gravitational field is very, very weak compared to the Earth, because the Earth is very, very massive compared to you. So to write this, you just need to follow what we have taught you, right, to describe this force. So the action-reaction pair of this particular force will be the force from Y. Just change this. So I use green, okay? Just swap the position, right, on Earth. Finish. You don't even need to give a name to this force. You are describing the force. So this is the description of the force. And of course, you need to talk about its magnitude, that they are the same. And you can see here, the direction is opposite. It's not different direction. Different direction, when you say different direction, and when you say opposite direction, they are different. When you say different direction, this is what it means, right? So this is down, this is right, this is different direction, right? But when you say opposite direction, this means if this is down, then this must be up. This is opposite direction. So do take note, the two of them. Okay, so I want you to do your own correction, refer to your homework, refer to your term test. How do you describe action-reaction pair? Okay, so like I said, the weight action-reaction pair is not your normal contact force. If you think about it, what is normal contact force? Normal contact force basically is the force from the floor on the object Y. Can you see that it is still acting on the object Y? Okay, so they can never be the action-reaction pair when both of them are acting on the same object. If you are still not getting this, please seek help from your teacher. You are supposed to find out what you don't know before the exam so that you prepare for the exam. Okay?